All right, I want to solve this simplex problem here. It comes from WAMAT. It says a little kid is running a lemonade stand that sells small and large beverages. Each small beverage sells for $2, and each large beverage sells for $3. Small beverages require 4 lemons and 6 tablespoons of sugar, and large beverages require 5 lemons and 10 tablespoons of 10 tablespoons of sugar each. She has 100 lemons and 180 tablespoons of sugar. How many of each beverage should she make in order to maximize her earnings? So it gives you a nice hint there that the unknowns, the things that we don't know, are how many small beverages and how many large beverages to make. So let's start with that definition, that X is the small beverages and Y is the large. And it's actually the number of beverages that we're going to make. And we've got a couple of constraints. We've got a limit of 100 lemons. And so I know that however many lemons I use, it has to be less than or equal to 100. The small beverages uses 4 lemons. So 4 times X will be how many lemons I'll use making small beverages. And 5 times Y is how many lemons we'll use using the large beverages, and I know that's got to be less than or equal to 100. The other restriction we have is the 180 tablespoons of sugar, and each small beverage uses 6 of those, and each large beverage uses 10 of those. And we also have our objective function. So we have these 2 restrictions along with the standard X has to be greater than or equal to 0. Y has got to be greater than or equal to 0. We can't make a negative number of servings of drinks there. It has to be positive. It could be 0. We don't have to make any, but it has to be. Can't be negative. Has to be greater than or equal to 0. And the objective is to maximize our revenue, which would be maximize our earnings, maximize our revenue. We don't know anything about cost, so it's got to be 2x plus 3y equals r. All right, let's convert that into a simplex tableau. What I'm going to do is I'm going to add an s and a t in here into each of those 2 constraint equations to make them, change them from inequalities to equalities. Let's introduce the 2 slack variables. I'm going to move the 2x and the 3y to the same side of the equation as the r. I'm going to subtract those. So I've got all the equations as in the same form of a variable plus a variable plus a variable equals to a number sort of thing, so that all the variables are on the left and then there's a number, just a number all by itself on the right. So 4, 5, 1 for the s. There's no t, there's no r in that first equation, and that's got to add up to 100 for our first equation. I've got an x, a y, s, t, and r are going to be our columns. 6, 10, 0, 1, 0, 180, and -2, -3, 0, 0, 1. 0 to start off with is our objective function. All right, first we want to identify the pivot. The pivot's going to be the column with the largest negative in it. It's going to be the -3. Technically, it's the smallest number in there. -3 is smaller than -2. And then I want to take the values in that column and divide on the far side. So I want to take 100 and divide it by 5. That's going to give me 20. And 180 divided by 10 gives me 18. And again, I want to take the smaller of those 2, smaller that's positive. So that's going to be the 18 is the smaller of the 2. And so that tells us the 10 back here is going to be our first pivot. I want to turn that 10 into a 1. So I'm going to take 1/10 times row 2 and put it into row 2 spot. That will give me the matrix 4, 5, 1, 0, 0, 100, 0.6, 1, 0, 1, 0, 1, or 18, And the bottom row is going to stay -2, -3, 0, 0, 1, 0. And now I want to do row operations to make turn the 5 in the first row into a 0 and the 3 in the bottom row into 0. And I have to use the pivot row. That's the restriction on the simplex method. You have to use the pivot row to do these. With Gauss-Jordan, you could use any row you wanted to combine them to make the zeros. But on the simplex method, you have to use your pivot. So I'm going to take -5 times row 2, add it to row 1, and put that back into row 1 spot, because that'll be a -5 times the 1 plus the +5 will give us 0. And I'm also going to do 3 times row 2, or plus row 3, and put it in a row 3 spot to create the 0 below that. So I'm doing these two operations at once. Oops, I forgot to divide that one by 10. It should be 0.10. 0.1 in there, not 1. And 18 down here at the far side. My writing's kind of atrocious here. Middle row is going to stay the same, and I'm going to do these operations. I'm going to take -0.5 times 0.6 minus 0.5 times 0.6 should give us 3, -3. -3 plus 4 gives you 1. -5 times 1 plus 5 would give us 0. -5 times 0 plus 1 gives us 1. -5 times a -0.5 is a -0.5. And if I add it to 0, I'll get a -0.5. 0 times -5 plus 0 remains 0. -5 times 18 is 90. And 90 plus 100 is 10. All right. And then let's do 3 times row 2 and add it to row 3. 3 times 0.6 would be 1.8. And if I add that to the -2, I'll get a -0.2. 3 times 1 plus 3 gives us 0. 3 times 0 plus 0 gives us 0. 3 times 0.1 plus 0 gives us 0.3. 3 times 0 plus 1 stays 1. And 3 times 18 is 54, I believe. Is that right? Yeah, 54. All right, so I've got a negative in the bottom row, so I'm not done yet. I got to do another pivot on this one. There's still a negative on the bottom row. I want to take 10 and divide it by 1. I'm going to take the number in the column, divide it by the value, that's what's there. 10 divided by 1 is 10, that's nice. And then 18 divided by 0.6, 18 divided by 0.6 should be something like 90, I believe. It's certainly going to be bigger than 10. So, well, let me double check here. 18 divided by 0.6 would be 30. So yeah, it's definitely much larger than 10. So our pivot column is going to be the 10. Our pivot row is going to be that first row. Again, you want to take the smaller of those two numbers. So our pivot is the 1. And so I want to use that 1 and create zeros below the 1 there. So if I take minus 0.6 times row 1 plus row 2, put it in a row 2 spot, that will create zeros going across row 2. And then I want to do a positive 0.2 times row 1 plus row 3, put it into row 3 spot. I'm going to leave row 1 the same at this point. And then if we do our math, negative 0.6 times the 1 plus the 0.6 gives us 0. 0 times negative 0.6 is 0, plus the 1 gives us 1. Negative 0.6 times 1 plus 0 is negative 0.6. Negative 0.6 times a minus 0.5 gives us 0.3. and then, I need to add it to the +1, so that would give us 0.4. Negative 0.6 times 0 plus 0 stays 1. A negative 0.6 times 10 is 6. Negative 6, add it to the 18 would give us 12. And then the bottom row, negative 2 times row 1 plus row 3. So negative 0.2 and a positive 0.2 add to 0. 0 plus 0 stays 0. Multiplying row 1 by 0.2, adding it to the third row is going to be a 0.2 there. Negative 0.5 times 0.2 plus 0.3 gives me a plus 0.2. And 0.2 times 0 plus 1 stays 1. And 0.2 times 10 is 2. And if I add that to 54, I get 56. All right, so I've got no more negatives in the bottom row. Everything is positive. That means I'm at the ideal solution. And from the first equation, I can read off here, this is the x column. It looks really nice. And x lines up with a 10 way over here at the far side, so x would equal 10. The y column is that 0, 1, 0. That's one of our keeper columns. That's one we want to keep. And so we get y equals 12. And s is a messy column. It's full of numbers there. I'm going to set it equal to 0. T has to equal 0 as well because it's a messy column. And then I get r equals 56. So the most revenue our person can bring in is $56 if they make 10 small drinks and 12 large drinks. All right, and just a little bit more about why we're setting the columns equal to 0. Each one of these is an equation. Each column here is an equation, and we can convert it back to an equation. And what we have is 0.2s plus 0.2t plus r equals 56 is that bottom equation. If you take that and solve for r again, if you move the minus 0.2s, subtract 0.2s from both sides, and subtract 0.2t from both sides, you'll get r is equal to 56 minus 0.2s minus 0.2t. What if I want to do, if I want to try to make either one of these bigger, if I take s equal to even 1, what's going to happen is I'm going to have 5 minus 0.2. S and t have to all be positive. All our variables have to be positive numbers. You can be 0, but you can't go negative. If I do anything other than 0 for s, what I'm going to do is end up subtracting from the 56. And my goal was to try to make r as large as possible. So what I want to do is make s equal to 0 because of that. Otherwise, I'll be subtracting away from my r. And similarly, t would be, because it's got a negative value, when you swap it to the other side of the equation, it becomes negative. If t is anything other than 0, it's going to subtract from the 56. It's going to make the 56 smaller. And so that's why I want to set s equal to 0 and t equal to 0. Otherwise, I'll be subtracting from the r value there. And so that's kind of why I'm choosing s and t to be 0. But if s and t are 0, then the other two equations, the top equation is x plus s minus 0.5t equals 10. But s and t we decided were 0, so that leaves us just with t equals 10. And the second equation is y minus 0.6s plus 0.4t equals 12. And again, if s and t are both 0, because those are the ideal solutions to do, is to make s and t 0, I get t equal to 12. So that's kind of the long way to come up with the answer. The short way is you just look for the nice columns of 1s and 0s, and then wherever the 1 lines up, if you've done the simplex method correctly, that's where your values will be. All right, there you go. Good luck.